So in this question, we want to solve the initial equation 2 to the power of x is equals to 16. Now to solve this equation, um, you know that on the left you have 2 to the power of x. So on the right, we have the number 16 and we're going to write it as power of 2. And that's going to be 2 to the power of 4. And on the left here, you already have 2 to the power of x. So now you can see on both equation side, you have 2 to the base. And so we're going to cancel the 2 and the 2 because they are the same. And then you write down the powers. So x is equals to 4. Now, in the second equation, we want to solve the equation 6 to the power of x is equals to 36. Just like we did the previous, we see that 36 can be written in powers of 6 because on the left is 6. So we can write 36 as 6 to the power of 2. And then you have 6 to the power of x already here. And then you can see that on both sides of the equation, you have 6 as the base. So we're going to cancel out the base. So what we'll have left is x is equals to 2. Now, in the next question, we need to solve the equation. Say 27 to the power of x is equals to 1 over 9. Now, there's no nicer way to write 27 as power of 9, okay? So what we're going to do is see what these numbers 27 and 9 have in common in terms of base. Now, we know that 27 can be written as 3 to the power of 3, okay? I'll put that in bracket, and this is the power of x. And this 9 can be written as 3 to the power of 2. Then we can write this as 3 to the power of negative 2. And on the other side here, on the left, it's going to be 3 to the power. Now, 3 multiplies x, that's 3x. Again, you can see what happens here. We have the same base 3 and 3, and they can cancel out. So what we have left is the power of 3x is equal to minus 2. And obviously, from here, you can find that the value for x is going to be minus 2 over 3. In the same way, we can, you have another question like, looks like it. Maybe you want to solve the equation 2 to the power of x, and that's equals to 1 over 32. Again, you recognize that you can write 32 as power of 2 as 1 to the power 2 to the power 5, right? And on the left, you already have 2 to the power of x. And we can write this as 2 to the power minus 5. And here it remains the same as 2 to the power of x. Again, you can see that on both sides of the equation, you have 2 to the base, the same. So all we need to do is to take the powers, which is x, bring them down, and that's equals to minus 5. Another example that we may want to consider is where we need to solve the initial equation, 64 to the power of x, and that's equals to 4. Now, I see that because here is 4, of course, you know, here 4 is in as 4 to the power of 1, okay? Now, I can write 64 in terms of power of 4, a base of 4, okay? That would be 4 to the power, I think 4 to the power of 3. So that's 4 to the power of 3. Kind of put that in bracket to the power of x, and that's going to be 4 to the power of 1 on the right side. And then you can expand the bracket in terms of using the lowest indices. So this is going to be 4 to the power 3x, and that's equals to 4 to the power of 1. Now, you can see that the power of 4, the base of 4 can cancel all out, leaving out the powers, which is 3x equal 1. And of course, x definitely going to be 1 over 3. There's another one here I want us to look at where we need to work out the equation for x, 81 to the power of x, and it's equals to 9. Just like the previous, we can see that this 9 is sent as 9 to the power of 1. And we can write 81 in terms of 9 in base of 9, and that's 9 to the power of 2. And you close out the bracket, and then put the x there, and here it becomes 9 to the power 1. And of course, you can expand using the law of indices. So it's going to be 9 to the power 2 times x is 2x, and that's equals to 9 to the power 1. Again, on both sides, you have 9 at base, so you're going to cancel that out, leaving out the power, which is 2x equals to 1. Obviously, to get x divided by 2, and x is going to be 1/2. Now, there's another one here we need to work out, and this is to solve this initial equation. 3 to the power of x is equals to 1 over 81. Now, we can write 81 as, because here is 3, the base 3, we can write 81 in terms of 3 to the power of 4. And the left is the same as 3 to the power of x. And we can rewrite this again as the right one as 3 to the power minus 4. And the left remains the same, 3 to the power of x. Again, you can look at both sides. They have the same base 3 and 3, so you're going to cancel that out. So you pick the powers only. So you have x is equals to minus 4. So we just have to take one more, one question. And that's where we need to simplify the equation 1 over 64 in bracket to the power of x, and that's equals to 256. Now, I'm looking at this, and I'm thinking, what does 64 and 256 have in common when you take them in powers? I see what is common could be 2 to the power of something, because I see that 64 can be written as 2 to the power of 4. Oh, 2 to the power of 6 rather. And of course, and then close that bracket to the power of x. And I know 256 can be written as 2 to the power of 8. And inside the bracket, you can write it the same thing as 2 to the power minus 6. And close the bracket to the power of x, and that's equals to 2 to the power 8 on the right side. And of course, if you expand this, you're going to have 2 to the power minus 6x, and that's equals to 2 to the power of 8. Now, let me move this a little bit to the left. Now, you can see from here that they have the same base 2 and 2, so this cancel all out. They have the same base, so they all cancel out. And then take the powers, which is minus 6x equals 8. And to get x, what you do, you divide both sides by minus 6, and that's 8 divided by minus 6, which will simplify to minus 4 over 3.